Hello guys, today I'm going to show you how to solve a Leetcode and Leetcode problem, graph valid tree. I'm going to solve it on Leetcode because I'm not subscribed to Leetcode Premium, and this is a premium problem. So for this, we have to do pretty much two things. We have to ensure it's a tree, and so that all nodes are connected, it's undirected edges. Also, we need to make sure there's no cycles, because if there's a cycle, it's a graph. So there's two big parts of it that we need. One that we go to every node, and one that we don't form any cycles. And so to start this off, we're going to create an adjacency list. I'm just going to do a little bit of comprehension right here really quick. We can then do for, I'm going to call it source, destination, and edges. And key part here is it's undirected. So we're going to actually do adjacency source dot append destination. Actually, the opposite. Adjacency destination dot append source. And we can actually do a check even before all this for efficiency's sake. We can say if the length edges is greater than n minus 1, we can just return false here. And this is because now there's too many edges. It's pretty much guaranteed to be a cycle because in the constraints, it says only going to have valid edges. Again, just return. Continuing on, so we have our adjacency list. We need a set called visited to make sure we've visited everything. And we've visited every node. We're going to DFS. For this, we're going to use a node, and we're going to have its parent. And in the end, what we're going to return is going to return DFS 0, -1, and the length visited equal n. When we return this in the end, we'll ensure that from just checking, just supplying one node, we've reached every node here that's length visited, and also this DFS ensures there's no cycle. And we'll check that here. What we can do. So if node in visited, we can return false here. This is our cycle detection. So we know at this point there is a cycle. And if not, we can keep going on. We can now at this point say visited add node. We can say for neighbor in adjacency list bracket node. Now we run the DFS across this. We do have to check for one thing though. So neighbor equals parent. Since this is undirected, we don't need to go backwards. You just hit continue. And you then can say if DFS or if not DFS is going to be neighbor. And for the parent, we're going to supply node. If not DFS, return false. And if this all passes, we know we can return true. A little bit of cleanup. We then can turn true. Let's give this a run. Looks good there. Hit submit. All right, good to go. Thank you.